Okay, we will start in. So before I begin the presentation, I'll just say thank you, everybody. Welcome and happy to have you here. Thanks for attending. Um, sort of usual housekeeping rules. I see everybody's on mute. I'm certainly happy to take questions. You can put questions in the chat, or you can come off microphone, come off mute, and either on video or just by voice, you can give me questions. I am going to give a short presentation on the FAR 3000 series chart radar, and talk about a couple of associated technologies, and then we can have some question and answer at the end. So I'll just introduce myself. My name is Matthew Wood. You can call me Mateo. I have been working for Furuno for 23 years. I started in the commercial fishing industry, working in Seattle, Washington, and working in Alaska, primarily in Russian fisheries. So I worked for several years in the United States and over in Russia doing fisheries business development. Also became familiar with commercial transportation. Worked for a short period of time selling commercial fishing gear, and then made the transition full-time into marine electronics in the year 2000. 2001, I worked for JRC. I worked for Japan Radio Company. And in the middle of 2001, I came to work at Furuno USA. So I am the national sales manager for Furuno USA. Even though Furuno USA did not change our name, we are responsible for sales, service, and distribution for all of the Americas. So North, Central, and South America. We became responsible for Mexico and the Caribbean, as well as Venezuela in 2015. And then in 2017, we became responsible for distribution and support for Latin America. So we've done very good work with ITEC Colombia. We can talk about a couple of examples of their work. I have a number of guys that work for me in the United States. I do have one contracted representative for Latin America, whose responsibility does not include Colombia. We are, first and foremost, we really just want to make sure that our partners and our customers have access to our information and have access to our resources. So you can certainly, I will, hold on a sec here. I'm going to put my email in the chat. So if anybody has any separate questions after the presentation, or if you have questions in general about distribution or other Furuno products, you can contact me at any time. So with that, I will start a short presentation on FAR 3000 series chart radars, and I will just ask Engelbert to confirm that we're okay. It looks like it's all right. Okay. So give me a sec here. Oh. All right. So just a short background on the FAR 3000 series radar and INS. We want to make sure that we draw a distinction and say that there is a difference between a kind of regular radar and a chart radar. I think everybody in the audience is familiar with what a radar does. A chart radar adds a lot of capability, and it also adds a certain amount of complexity. So when we say INS chart radar, this means that this is primarily a radar for, a navigation radar, but it has a chart underlay. So rather than having an ectus where the chart is on top, rather than having an ectus where the chart is the basis and you have radar overlay on top of the chart, in this case, we have a radar with a chart underneath the radar. So it's a little bit different. Depending upon how the radars are put together, we can have only radar image or only chart image, or we can have a combination of the two. And there are some installation and regulatory advantages that we can take advantage of when we have a chart radar as opposed to a separate radar and a separate ectus. So what the FAR 3000 chart radar series is a networked MFD or multifunction display radar series. In their basic configuration, you have we have several configuration of X and S, but in the basic setup, it is a radar where charts are loaded for situational awareness and chart navigation. These radars are available. We are the first company to have fully available magnetron and solid state antennas. So, and we'll look at some of the specifics there. We have we introduced the FAR 3000 series radars in 2013. We sold our first solid state S band radar in 2013. So we are now at the 10-year mark. And in fact, we actually have introduced Mark II radars. All of the information that you will see in this presentation is valid for both Mark I and Mark II product. And I can talk at the end just a little bit about the difference between the Mark I and Mark II. So, but the main distinction for anybody who is familiar with our radars prior to the FAR 3000, this was a very new design gearbox and new antennas. We actually have changed the antenna presentation for the better. So we have better transmission technology in the gearbox or the turning unit, and we have a more efficient open array. Another big development in particularly for an INS radar is that we have wide and high definition compatible displays. We have seen primarily in commercial new buildings as well as government and military new buildings a desire to have much larger displays. So really our standard display at this point is a 27-inch. This has also changed because of some changes in the LCD and display industry. A few years ago, the standard display sizes were 19 and 23, and now we are seeing 26 and 27, 24-inch displays, and some even larger, and we can do all of those. So having a high definition video output, actually multiple video outputs from these processors, is a large advantage for us. And then this last bullet, multifunction display. So when we move from a radar to a chart radar, again, we have the element of radar and chart. So we can do both target detection and we can do navigation. When we move into some of the advanced implementations of MFD, this is where we can also add conning. One thing to understand about our chart radars in ECDIS is that conning is built in as a standard offering. It is not an option. And then depending upon the interfaces and depending upon the equipment on a vessel, we can also make the FAR 3000 and 3005 series chart radars. We can make them part of an alert management system or alarm management system. So you will hear, I like to say alphabet soup. We have lots of acronyms. So we have BAMS or BAMS. We have CAMS or CAMS. So that's a bridge alarm management system or central alarm management system. The FAR 3000 and 3005 series radars are capable of acting as central alarm port management systems in a large distributed INS or integrated navigation system. And then both the FAR 3000 series radars and some of our other radars do have advanced applications with additional processors. We can add additional processors for, you can see, oil spill detection, ice detection and ice navigation. Maybe not so important in Colombia, but for anybody doing a mission at the North Pole or the South Pole navigating in ice, we have that capability. On oil spill detection, it's quite important to know that a navigation radar will not be sufficient for oil detection on the water. You have to have additional video processing from a secondary processor or a very specialized oil radar. So the great thing about the Furuno navigation radar combined with a secondary processor for oil is that we retain all of the navigation features in the navigation radar, and we have oil detection and threat detection with the additional processor. And then we also have a wave height detection additional processor that that does much of the same thing that the oil radar does. It creates composites. It creates a number of different layers of radar to be able to distinguish very, very small targets, very fine targets. So moving on, we will look, I will show you some videos at the end of the presentation. Some of the really critical factors that we have in the FAR 3000 series radars are these that you can see on screen. So ACE, or automatic clutter elimination. This is both when SS means solid state and MG means magnetron. So this is really a one button push feature to be able to eliminate all clutter on the screen. And it is particularly optimized for operating in port and harbor environments. So if you're in a very, very busy traffic area with a lot of targets, and also a lot of false targets. So if you are operating, if we have a vessel that is operating in the harbor in Cartagena, or in the harbor going up the Santa Maria River, this is literally a one button push that can eliminate all of your clutter. And we'll show you a visual example of that in a little bit. Interference rejection is also very important. As there are more vessels in the world, there's more radars, and more radars means more interference. So we have significantly changed and improved our interference rejection so that we can operate in a very busy, very noisy environment. If you think about harbor in Cartagena, there may be 100, 150 or more vessels operating. Most of them will be transmitting radar. We have to have a way to tune out that radar interference. Improved target tracking. This is something that's easier to show visually, but it's very important to note that in all of our current radar series, we are doing ARPA or radar target tracking in the background all the time. So from the time that the radar is turned on, all of the target information is constantly being tracked. There is always a time when the radar is identifying a target and tracking that target. And we as operators, we are simply making a decision to show or hide that information. But the information is always available to us, and it's a very powerful feature. And then another major change from our previous radars going back more than 15 years is that with our solid state product offering, we are offering Doppler echo detection filtering. So we are tracking the Doppler speed radial velocity in increments of 1 knot from -31 to +31 knots to be able to give a much more precise value for our traditional ARPA values like CPA and TCPA. Excuse me. So when we are identifying closest point of approach and the time to closest point of approach or time to collision, we have a much more elegant, much more sophisticated way of doing that. In the FAR 3000 series, we have a very new antenna profile. Excuse me, just one second. You can see here, and this is just a visual representation. We have lots of different photos. So one thing to bear in mind about these antennas is that they are all digital radar sensors, meaning that the principal target processing is happening inside that antenna. So you can see that the CPU board, the central processor, is actually located inside the radar antenna, and there's no cooling fan required because of the digital nature of this construction. We have an improved and integral performance monitor. This is more important for commercial vessels, but in certain scientific applications and in certain naval applications, there is a need to provide performance monitoring. All of that is internal to the radar gearbox now. You can see, I will just point out, if I grab, hold on a sec here, I'm going to grab a little laser pointer. There we go. So you can see here that we actually have an external cable gland coming into the gearbox. We also have the ability to do an adaptation where the cable comes directly into the bottom of this gearbox. So we do have this external cable gland, or we can do an internal cable gland as well. You can see in this case with the new antenna design that we have a round antenna in the FAR 3005 series. In the S-band radars, we have this very sleek, flat or rectangular design, which is much better for resisting wind loading, particularly in very bad environments. I think everybody knows we have had 3 hurricanes hit Florida this year. Fortunately, none in Colombia, and hopefully you guys can avoid that. But we have to have radar operating in very high wind speeds. And so the FAR 3000 series radar, the FAR 2XX8 series radar use commercial gearboxes that are guaranteed to operate in speeds up to 100 knots of wind. You can see here that the radio frequency unit is completely integral and removable for the S-band. This is a change from our previous radars. So you can see in this image, and I have some other images that I can share as well, that you can remove just one plate from the side of the radar and remove the entire transceiver unit. We call that a sled. So for a technician or for any kind of preventative maintenance schedule, it is very easy to take one cover off the side of the gearbox, either X-band or S-band, remove an entire transceiver unit and replace it with a fresh transceiver unit. Not required so much with solid state radars, but for anybody who has to change a magnetron, this is a very easy way to do that. That entire process can be done in less than 20 minutes. So this is why we concentrate on selling TR upmast 2-piece radars, because we've made maintenance very simple. All of these radars offer DC brushless motors. You can see this. So there is no requirement to change brushes in the motors anymore. Motors do need to be replaced, but we normally see motor replacement in excess of 50,000 hours. So magnetron replacement, generally we will recommend at 5,000 hours, but the motors can keep going and going and going. So they are DC power, and they are brushless. Bear in mind that we are converting AC to DC power to power these radars. Although we do offer, in certain cases, we do offer AC or DC power as the main power for these units. And then again, just another note, you can see that this is a much slimmer S-band antenna, operates better in wind and puts less stress on the motor. So when we talk about scalability, it's very important to note that we can build a system that is very minimal, or we can build a multi-station setup. So in this image, you can see that we have a central processor unit. Furuno was the first company to offer what we refer to as a black box system, very similar to like a desktop personal computer. You have a central processor separate, you have a display, and you have a separate keyboard. Here we have the same thing. We have we have the radar antennas that are connecting to the processor. We have a separate keyboard or control unit. We have video output, actually 3 video outputs to different displays for radar and chart display and conning. And you can see that we have displays from 17 to 27 inches, and we can actually go a little bit larger. We can have an additional trackball, or if we have a very small space, then we do have the ability to eliminate the large keyboard entirely. We can control the entire chart radar just from a trackball controller like this. And if we want to build this out, we can have multiple processors. We can have multiple processors for a single antenna, and we can build very large networks. Our largest INS network to date, our largest FAR 3000 system to date, is on the training ships for the United States Navy and United States training academies. We actually have 2 bridges on the training ships. We have 5 antennas in one bridge and 3 antennas in another bridge, with a total of, I believe, 12 processors. So very much the same way, because we are leveraging network and standard Ethernet, we have the ability to have a number of sensor arrays and then simply a number of workstations. So if we need 2 workstations, no problem. If we need 5 workstations, also no problem. So when you think about the anatomy, or you think about the layout of a commercial ship bridge or a military ship bridge, we may have a need for a radar in the central navigation bridge of the vessel. In a military context, we might need to have a secondary radar in CIC and command and control. In a commercial application or in a military application, we may need to have workstations at the bridge wings. All of this is possible by having a scalable radar network like this. While we do have some limitations, it's also important to note that if you have an existing Furuno radar from approximately 2005 or 2008 until the present time, we do actually have the ability to reuse the antenna cabling in many cases, especially for magnetron radars. If we have an existing radar unit, we can also convert those radar images to fiber optic, and we can run very, very long distances. It does require adapters at either end of the cable. So I'm going to come from my antenna to an adapter into fiber, bring my fiber into another adapter, into my processor, and into my control mechanism on the bridge. So, and then another important note is that if you have a Furuno radar that is 25 years or maybe even 30 years or less old, all of the antenna mounting hardware is the same. The footprint of the radar and the bolt holes is the same. So we will not require hot work for replacement of a radar. So if you have a radar that's 15 or 20 years old and it's time to replace it, you simply undo the bolts on the gearbox, remove it, put the new radar in place. You might have to make a small cabling change. We make it much, much easier without having to run completely new additional cable, and with no hot work, with no welding on the mast. Some key features that we have, and this is important both for radar and especially for chart. So internal to the processor of the radar, we can offer a playback function. So this could be for accident analysis or incident analysis. It is also used for training. If we can bring that information in, store it on the hard drive of the processor itself, or you can attach a separate hard drive and store potentially years of voyage data. So this is similar to, but it is separate from, a voyage data recorder. And Furuno also offers voyage data recorders. The undo function, if particularly in route navigation or in waypoint navigation, if a navigator makes a mistake, enters an incorrect point, or makes any kind of incorrect step, you have basically a go back button or an undo button. And that is basically unlimited going forward. And then in newest software, we actually have a redo button. So if you back up and you decide, no, I actually did want to do that, then you can also redo the same action. And another powerful feature, and this is related to playback, but it's a little bit different. You can see the camera icon there in the lower left. So all you have to do is press that button and you can store up to 100 images. The easiest way to do this is simply plug a USB stick into the processor and you can capture 100 images. This is also used for training. We are actually we are using the screenshot function for this presentation. We are taking some of those images directly from the radar processor. So this becomes a powerful tool a number of different ways. If for example, in a maritime college or in a training evolution, if you want to, let's say that you have your master navigator who is conducting kind of the perfect approach to port, and this could be commercial or it could be government. If I want to show trainees, if I want to show cadets how something is done, then I have my senior captain do an approach, do whatever navigation maneuver is. I save screenshots every 3 minutes or every 5 minutes, and then I can build a training presentation or even build a training movie for any of those maneuvers. A very powerful feature that has been used quite a lot by our military training academies. Also important for shift change, and this is also in the commercial and military environment, we do have the ability to store custom user settings. So if the captain is handing off the watch to the third officer, or the third officer is handing off to the second officer, they can preload particular settings. So if there is a particular way that they want to see their navigation display that is specific to them, all they have to do is they can plug in a USB dongle, they can select their own user profile, and then all of the data will be presented in their format. This is also important from a training and standardization methodology. So particularly with government and naval forces, this is really good for setting a baseline data presentation for all radars. So if the Navy, let's say the Navy has 15 vessels and you want a complete standard for data presentation, you can effectively clone these processors so that they're all presenting the same data in the same way. But we feel it's also important to have a level of customization. Those user profiles could also be considered mission profiles. So if there was a navigation profile, let's say there was an open water navigation profile, a harbor navigation profile, if there was a defensive stance profile, those are all data presentations that could be loaded and accessed as defaults. And then on the ECDIS side, or on the chart side, we do have auto chart uploading. And this is a really attractive feature. We can, if we introduce charts into the processor using standard media, like a DVD player, or more often it's simply going to be done with USB stick, then we can load those charts. If I have a 5-node chart radar installation, all I have to do is load charts in one of those radars, and that chart radar will automatically copy those charts to any other processor that is in the network. So if you have a radar maintainer, he doesn't have to take the USB stick out and go to every processor in a very laborious process. This is the great benefit of standard TCP IP internet, or what we call IEC 61162-450. 450 is the Ethernet standard, so that is commercial Ethernet brought into our marine navigation devices. So here, I will show. I'm going to get out of the presentation in just a minute, and I want to show each of these individually. So, give me just a second. I'm going to stop sharing that because it will be easier for me to do this from a file. Here we go. So give me just 1 second. All right, hold on a sec here. Okay, so I want to show just a short video for you to show quick start. So this is our solid state S-band, and in this case, it is a solid state radar, and it's a solid state S-band. And because this movie goes fairly quickly, I just want to show you something. This is showing the initialization, turning the radar on, and then first transmit. So as I roll this, you can see the radar is off, and then the radar is on, and you will see the radar sweep start to kick in just a couple of seconds. So we go from dead radar, zero power. We apply power, and then we can start transmitting. So that, as I was talking, that was 9 seconds to go from dead radar to transmission. You can never do that with a magnetron radar. So, in particularly in the military environment, and this is true of our small radars as well as our big radars, it's very, very important to be able to begin transmitting right away. So that's just an example. That is one example um, of our quick on. Then I also want to show you, get this going real quick, stand by. So this next clip that I'll show you, here we go. So before I roll the video, I'll just sort of explain what this image is. So this image here, you can see my cursor. You can see radar targets. So this is obviously, this is the harbor by FEC headquarters. Furuno Electric is in southern Japan, on the southern island of Japan. It is a very, where Furuno is located is basically an inland sea. It's not referred to as a harbor. It is actually referred to as its own small sea, Osaka Wan. We are located in the Osaka region, and if anybody has ever navigated, if any of our government visitors or commercial visitors, if you have ever navigated not into Tokyo but into Osaka, it is basically an enclosed archipelago on the southern coast of Japan. It is a very, very, very busy traffic area. Thousands, tens of thousands of vessels transiting this area. It is also a very messy target area because there are a lot of buildings. There's a lot of coastline. There are a lot of high-rise buildings. There are a lot of warehouses. And anytime you have that flat metal surface, that will serve as a reflector for radar energy. And so it can make a radar picture very, very poor. What I'm going to do is I'll just call your attention to a couple of buttons. So this is our ACE feature. So you see right here, there is this button entitled ACE. So again, that is automatic clutter elimination. It is a one button press to clean up the screen. And it's particularly effective in a harbor environment like this. In the open ocean, it doesn't make such a big difference unless we have a lot of vessels around us. But in Cartagena, in Los Angeles, California, in New York, or in the Panama Canal, you're going to have a lot of vessels, you're going to have a lot of buildings, you're going to have a lot of coastline that will act as a reflector that will scatter radar target energy everywhere. So I'll just show you this. So we'll roll this video. So you can see our radar targets. You can see all of this blue stuff. You can see these false targets in here. We're going to bring our radar cursor, and the radar cursor will come up and it's going to click on the ACE. So you can see the cursor here. We're going to come and click on that ACE button here in just a second, and you will begin to see the screen clear up very, very quickly. So there is ACE goes from off and no goes to on. And you will see immediately how clear that image becomes. So the blue, bear in mind that the blue are echo trails. That is an intentional setting. So if we want to not use ARPA, but if we want to use echo trails to track the relative motion of a target, this is the way that we do this. But you can see that all of that, all of that color, all of that kind of fake stuff and interference and clutter was eliminated in a harbor environment. And this is a busy harbor environment where right here we have probably 30 or 35 radar targets. Of course, these radar targets on land, those are going to be buildings, those are going to be high sites. So we do have the ability not only to distinguish our vessels on land, but we also have the ability to detect our buoys. So you can see very clearly here that there is a radar target on that buoy symbol, a radar target on that buoy symbol. We do have the ability to distinguish those. And then one more video that I want to show you just real quickly. And I'll set this up as well. Hold on. So as I mentioned at the beginning, when we are transmitting an FAR 3000 series or FAR 2XX8 series radar, the radar is always assessing motion. The radar is always basically performing target tracking. It's performing target tracking in the background. We may show or hide. The operator can make a decision to either display or not display the track target information here. So I'm just going to show you a short example of going into automatic target acquisition here. Give me just a second and I'll share this window again. So again, just to set this up, here is our own vessel position. You can see now we have added another layer of information. You can see these triangles, those are AIS targets. You can see that there's a radar target, or like with this guy, you can see very clearly that there is a red radar target associated with that triangle. There is a little blue trail coming from him up here as well. These are larger vessels, larger radar targets, also with the AIS symbology, and also with tracking, and also with echo trails on. Now, if I do what I want to show you and to pay attention to is how quickly the target information is presented. So we go into our live radar sweep. You will see the radar. You'll see the radar cursor activate. And as that cursor goes over different targets, it's going to show up in just a second here. There's the radar cursor. So that is a click and a target. Click and a target. Click and a target. So you can see traditional radar users are accustomed to a magnetron radar taking several sweeps, potentially 20 seconds or 30 seconds to generate an ARPA vector. Here, we can click on 100 targets and have that information available, again, because the target information is being assessed 100% of the time from the first sweep of the radar. So that that very, very fast radar target tracking is a huge advantage to the Mariner. All right, just one second. And there. So that's all I have for the presentation. I appreciate everybody's attention, and I am happy to take any questions that anybody has.
Muchas gracias, señor Matt. Si alguno tiene una pregunta, puede tomar el espacio o puede dejarlo en el apartado del chat.
And I see a few friends in here. Edwin, it's good to see you. Thanks for coming. Thanks for joining us today.
Well, ¿alguien tiene preguntas?
Un momento, déjenme ver. Matt, good day, how are you?
Good, thank you. Is that Carlos?
Yes, this is Carlos.
Hey, Carlos, good to hear from you. How are you doing?
Good, all good. Yeah, but this is just one information for the persons regarding the functions of this FAR 3000. It is good to clear if these all functions need any special key, or it is possible to buy the processor and it is coming with all these functions in one place.
Yeah, and if you want, I can say in English, and if you want to translate, yeah, all of the functionality that I have shown here, that is all built into the radar. That is a standard product offering. There are some advanced features that we unlock using different licenses, but that is more for if we are doing a very high class notation or like a very specific military or government bridge. But everything that you have seen here, radar functionality, so again, radar functionality, chart functionality, solid state or magnetron radar, the automatic clutter elimination, the quick the quick target tracking, and the quick startup, that is all standard 100% built into the product.
Okay. And in the case, for example, alarm management, this is a different license?
That is a different license, yeah. So where we see BAMs and CAMs, where we see that alarm management system start to kick in, certainly in the military and government environment, but especially in very high class notation vessels. So any vessel that carries oil and gas, any vessel that is involved in petroleum trade at all, pretty much by definition, especially larger vessels, FPSO, LNG carriers, even crude carriers need to have an alarm management system. So in an alarm management system setup, normally we will have 3 or 4 processors, usually 4. We will have one processor for X-band radar, second processor for S-band radar, third processor for conning, to have a specific conning page, and then the fourth processor there is really specifically to address alarm management. It is not just the fourth processor. That processor is loaded with special software, and there is a very distinctly different display. So you have radar image X-band, radar image S-band, conning, and you have an alarm monitoring screen that shows you all of the alarms for any of the equipment that is interfaced into the INS.
Okay, thank you, Matt. Does anybody more have any question, please?
Yeah, from Edwin in the chat, he says that the radar is free of maintenance. End of life of solid. Oh, okay. So, yeah. So the basically, what is the maybe not end of life, but the lifespan of the solid state radar? That's a good question. And preventive maintenance. So, good question. Let me address sort of three different topics. Going back to the presentation. So again, we have DC brushless motors. So you never have to replace brushes. Motors might have to be replaced every 5, 6, 8 years. That really, obviously, that depends on how much the radars are being used. With solid state radar, there is no magnetron to replace. So really, there is no maintenance of the transceiver. There's no maintenance of the transmitter. But in terms of overall longevity or the lifespan of the radar, we are building our radars for a minimum 10-year duty cycle. And normally what we are seeing is that the total duty cycle of the radar is between 15 and 20 years. So if you have a radar that is, and this is, I'll put it this way, there's only so much maintenance that we can do, right? There are simply going to be physical components that wear out. Metal is going to gall, particularly on vessels with a lot of vibration. That will be very hard on all of the other components. So this is where we generally say radars, a 10-year-old radar should be no problem. If we have a radar that is 13, 14, 15 years old or older, we can, if it's a magnetron radar, we can still replace magnetron. If it's old motors with brushes, we can still replace brushes. But there's not really anything that we can do about metal fatigue. So even a solid state radar, we would say plan to replace between 15 and 20 years. And then Gonzalo has a question. Is it possible to update 2018? Oh, so the 3200 radar to current version. So if it's a 2018, so if it's a 3200, if it's an FMD instead of an FAR, FMD would be the Ectus. FAR 3000, like FAR 3220BB. Yes, it can be updated. Basically, So if we have an older chart radar from 2018, so that's a 6-year-old radar. We definitely have repair parts. So if there is something wrong, we can fix it because it is out of warranty, but it is still a current product, and we can provide maintenance parts. If you want to replace the processor to have a new processor, that is also possible as well. Happy for any other questions.
Yes. Hi, Matt. Hi, all you guys.
Hey, Ender. Oh, we got some echo going on here.
You read me?
Yeah, you have a lot of echo, so you need to turn one set of speakers off.
Okay. No, voy allá donde.
Yeah, that's better.
Please wait a moment, please.
Yeah, no problem. Yeah, it sounds better now.
Okay, I think it's better now. Hi, all of you guys. Hey, Matt, you hear me?
Yeah, I can hear you fine.
Okay. I have just a question. Is the solid state radar IMO type approved?
Yes. Yeah. So we know that we were the first company to offer type approved radars in both magnetron and solid state. So, and it's important to note that because the radars are communicating by network and not specific cable, that you can have, if you want to have a magnetron X band and solid state S band, no problem. If you want to have magnetron X band, solid state X band, and solid state S band, 3 radars, also no problem. Yeah, so all of the radars are type approved. Just obviously, one thing to bear in mind is that for X band, for 3 centimeter radar, you have to have a minimum 6.5 foot open array. And for IMO type approval on S band, you have to have a 4 meter or a 12-foot array. We do offer smaller antennas for commercial fishing, for certain military applications, and for the yachting industry. But yes, all of the FAR 3000 X8, FAR 3005 radars, they are all IMO type approved.
Okay, thanks.
Of course. And then we also, of course, we are working in Colombia, as well as with other governments in Latin America and around the world. We have a couple of different partnerships. We have a strategic partnership with Wärtsilä for very high-end vessel traffic systems. But in our own product line, Furuno is 49% owner of a company called MAXC in the United States called Noveltech, and that product line is called Time Zero. So for coastal monitoring, harbor security, port security applications, we do have the ability of combining a chart radar with an electronic chart system for harbor security and monitoring. Edwin, good question. Thanks. Yeah, does the radar come with electronic charts? So you will need to buy charts, and charts. I could do probably a 4-hour presentation on charts. Don't worry, I'm not going to now. So with electronic charts, in the United States, we're very fortunate. Electronic charts in the United States are actually no cost. They are paid for by taxpayer money. In Colombia, you would have a couple of options. If you have the S57 ENC chart available from the Colombian Hydrographic Office, from the Colombian government, you would be able to take that data, put it on a USB, either on a USB stick or a USB drive, and you'd be able to load it in the memory of the processor. The other way that we provide charts, we can do it a couple of different ways, but we have a device called Gate 1. What the Gate 1 is give me just a second. I can show you an image. We do have, hold on a sec here. Oh. Sorry, I'm going to get to my website. I just want to show you something real quick. So I want to share here. Sorry, one sec. So this is in our website, FurunoUSA.com. You're welcome to this is a publicly available site. So you can see that this is a digital chart book and a data gateway. So we have worked with our partners at Furuno Finland. So they offer a number. So that I mentioned at the beginning of the presentation, we have the ice radar, oil radar. We have additional processing that we can do. Those are not included in the FAR 3000 series. The FAR 3000 series can integrate with that product, but they are separate products. This is also a separate product. The Gate 1 is an electronic gateway. It will connect to the satellite phone or maybe Starlink on a vessel, and it will automatically update charts. So Furuno Finland is a value-added reseller of the UKHO, the United Kingdom Hydrographic Office, and their AVCS service, the Admiralty Vector Chart Service. So we do have the ability to provide charts either for a limited area, or the Gate 1 and the FAR 3000 are also capable of providing what we call pays coverage, which is pay as you sail. So when a vessel has a Gate 1 on board, if a vessel is going from, say, from Cartagena to Hamburg or from Cartagena to China, you have the ability to automatically unlock charts for the FAR 3000 series chart radars and also for our FMD ECDIS. And that is, just generally speaking, with the Gate 1, the hardware cost is $1,100. The annual subscription is $1,800. That is the service. It's about $800 per year for pay-as-you-sail functionality. And then the UKHO standard pricing for a chart cell is $5.20. But the interesting thing about pay-as-you-sail is that you only pay for the chart for the time that you use it. So it's a very affordable way to do charts, especially for international voyages. Good question. Thank you. It can't read any electronic chart format. So in the world of ECDIS, so I also forgot to mention, this is kind of important. So ECDIS is ECDIS. If a military government vessel or a commercial vessel is required to have ECDIS, then you have to have ECDIS. Depending upon flag state, the FAR 3000 chart radar can be used as a backup ECDIS, not a primary ECDIS. So if you wanted to have a redundant system on your vessel, basically you would have one ECDIS, you'd have a backup ECDIS, and then you could also have the FAR 3000 series. So potentially in a simple installation, you could have one ECDIS and one chart radar for full redundancy of your charts. The same rules apply to the chart radar as apply to ECDIS. It has to be ENC. So that is S57 electronic navigation chart data as determined by the IHO, as determined by the International Hydrographic Office. In time zero, in our electronic charting system, we have the ability to display more charts. We can show S57, we can show S63. Time zero is also ready to go for S100. And then if there are specific chart formats, like in the United States, the US government uses DNC or digital navigation charts, we also have the ability to show DNC. So if the Colombian Hydrographic Office or if the Colombian Navy have something similar where the chart presentation is in that same format, then the electronic chart system would be able to read it. But otherwise, ECDIS, chart radar have to have S57 ENC. Thank you, Edwin. Those are great questions. Any other questions from anybody?
¿Alguna otra pregunta? ¿Alguien más tiene una pregunta para el señor Matt? Okay, Mr. Matt, thank you for your time, your presentation. So this is the end of the webinar. Or thank you for all, Mr. Matthew.
Yeah, thanks everybody for coming. And again, you can see my email in the chat. And if anybody has any questions, I know that we've got a couple of other dealers, but you can reach out to us through ITEC in Cartagena, and we welcome any questions. Thank you for coming today.
Thank you, Mr. Matt.
All right, guys. Have a great day. Ciao.
Thank you, Matt. Thank you, everybody.
Ciao, ciao.
Thank you. Ciao.